everyone. I hope आप लोग अच्छे हो and you people are solving questions, enjoying things. Let us for now get at this one. Work function of metal X is equal to 3.5 electron volt. So phi X is given 3.5 electron volt. ठीक है? Electron volt is also an unit of energy, and this is the energy that an electron gains when it is accelerated by 1 volt of potential difference. Okay, so this is this thing, and work function of material Y is equal to ionization energy of He plus ion in the first excited state. This thing is very important. अब देखो phi Y क्या होगा? So this is ionization energy of He plus ion in first excited state. So this is He plus, this is hydrogen-like element. So its energy can be indicated by minus 13.6 Z square by N square. ठीक है? Since Z here is 2, because this is not hydrogen, hydrogen-like rather. Why like? Because it also has one electron. This is He plus, right? So this is hydrogen-like. Now, Z का value आप 2 रखो, this will become 4. So this is minus 13.6 into 4 by N square electron volt. Now what will be the ionization energy here? It is He plus ka, I mean, yeah, what will be the ionization energy in the first excited state? So we need to talk about in first excited state, what will be the energy of He plus thing, right? I mean, what will be the energy of electron in the first excited state of He plus ion? So आप ध्यान से देखो, He plus ion कहने का मतलब कि हाइड्रोजन है, ठीक है, सॉरी हीलियम है, एंड इस हीलियम का एक ही इलेक्ट्रॉन बचा है, एंड दिस शुड बी ideally in the ground state, but since it is in the first excited state, so ground state meaning n is equal to 1, first excited state meaning n equal to 2. So this electron is not here, rather it got excited to this position and it is here. ठीक है, सो क्वेश्चन के अकॉर्डिंग He प्लस आयन है जिसका इलेक्ट्रॉन कहाँ है, फर्स्ट एक्साइटेड स्टेट में है, एंड देन इट इज सेड दैट आयनाइजेशन सॉरी work function of material Y is equal to ionization energy of this He plus ion. Done it? So what will be its ionization energy? Whatever energy this electron is having over here. So n equal to 2 में इलेक्ट्रॉन के पास कितनी एनर्जी होगी इन He plus थिंग? कितना होगा बताओ? n equal to 2 आप पुट करो यहाँ पे, minus 13.6 by 4 into 4 electron volt. So this is minus 13.6 electron volt. So this is having this much of negative energy. In order to take it out, you need to supply this much of positive energy. So phi y क्या हो जाएगा तुम्हारा, plus 13.6 electron volt. Done it? So two things we have got. Light of same wavelength is incident on both X and Y. Again, this is, let's say, X. On this, whatever photon is incident, it has energy of, let's say, E. And on Y also, whatever photon is incident is having energy E only. Then only their work functions are different. Also, they are different materials. The maximum kinetic energy of photoelectrons emitted from X is twice that of photoelectrons emitted from Y. So यहाँ पे K max का वैल्यू सपोज कर लो आपने, यहाँ पे K max का वैल्यू सपोज कर लो आपने K नॉट रखा, तो यहाँ पे कितना हो जाएगा? It will become how much? 2 K नॉट, right? Because it is 2 times that of Y. Now find the wavelength of incident light. So we have to calculate wavelength of incident light. तो बहुत easy है, हमें simply इक्वेशन यूज करना है फोटो इलेक्ट्रिक इफेक्ट का. सो इक्वेशन क्या होता है, देखो अगर लाइट फॉल कर रही है जिसकी एनर्जी एच सी बाई लैम्डा है, if it has a work function of phi, then whatever an electron is coming out, electron will come out if this energy is greater than that of phi or equal to, and if it is greater than phi, electron will come out with some kinetic energy, and that kinetic energy can be maximum equal to hc by lambda minus phi. So this can be maximum. Minimum it can be zero also, because when electron comes out, it may collide with the lattice of this structure, this plate or something, right? So internal lattice से अगर वो collide करता है, it may lose its kinetic energy and it may come out with zero kinetic energy. Done है? But K max will be this one. Now K max you write for both the cases. For X, if you write, that is how much? 2 K naught equal to energy of photon light, that is E, minus work function. कितना था बताओ? That was your 3.5, right? So here you write 3.5. And for this, you will write K naught equal to E minus how much? 13.6. Now you have to calculate wavelength निकालना है या एनर्जी निकालनी है, वेवलेंथ निकालनी है, ठीक है. सो आप पहले एनर्जी निकाल लो. तो एक काम करो, इसको आप 2 से मल्टीप्लाई कर दो. सो इफ यू मल्टीप्लाई इट विथ 2 एंड देन यू सब्सट्रैक्ट, ठीक है. सो यू डू दिस थिंग, व्हाट यू विल बी गेटिंग, ये तो जीरो हो जाएगा. And this will become how much? Minus 2e and e plus e, that will give you minus e, and this will be plus 13.6 into 2 है ना, minus 3.5. So this will be, e will be equal to how much? 23.7. ठीक है, इलेक्ट्रॉन वोल्ट. इन इलेक्ट्रॉन वोल्ट वी आर गेटिंग thing, right? क्योंकि this was in electron volt, this is in electron volt, so energy also we are going to get in electron volt. Now we have to calculate wavelength. So E meaning what? Hc by lambda. And Hc by lambda can be written in terms of electron volt, nanometer या Youngstrom, sorry angstrom. Here also that hint is already given. I mean Hc को क्या लिखना है? 12400 electron volt angstrom. So 12400 electron volt angstrom divided by how much? By lambda is equal to how much? Energy, that is 23.7 electron volt. This will get cancelled. So lambda is equal to 12400 divided by 23.7 angstrom, right? So this will give you how much? Almost 523 angstrom. So this will be your answer. I hope you have understood this question. This is a very basic one, I would say. But still, when we are starting with modern physics, we should know all the little and small and then the bigger thing in this topic. So we have started from the very basic or from the very beginning, I would say. I hope you have understood it. But if you have any doubt, you can always let me know in the comment section. Thank you. Take care of yourself.